Okay, so today we're going to be talking about glacial erosion. So I'm going to say there's four main ways that glaciers can erode the landscape. So the first one is by abrasion, which you might have heard of from rivers or just anywhere else really in geography because it's quite a common term. You then have plucking, you have fracture and traction, which I also like to refer to as subglacial deformation. I want to say deformation. That's how I like to refer to it, okay? And the last one is meltwater erosion. So I'm going to explain and draw how each of these processes sort of work, okay? Starting with abrasion. So abrasion is super simple, right? You have your glacier traveling along a surface. So let's get a blue glacier in, and basically down at the bottom of the glacier, subglacially, you have rocks, or unglacially, I suppose, but technically subglacially, you have rocks, right? And these rocks, as the glacier advances, these rocks abrade, so they abrade the bedrock beneath, and over hundreds of years, thousands of years, you get striations, which are just really long sort of marks left from the erosion of rocks. And you also get sort of more rocky debris that has just kind of been abraded out of the bedrock. And basically, when the glacier has melted, you get you are left with a landscape that is, let's get a rubber again, slightly there might be slight depressions in the landscape, so you might have slight depressions here and here where abrasion has particularly occurred, and you'll have lots and lots of striations, which I've already mentioned are just marks left by the scraping of a rock on the glacial bed, the bedrock. Okay, so that is abrasion done. Now next we have plucking. So let's draw a bit of a landscape again. So you've got your landscape and you've got your glacier. So what I failed to mention actually for abrasion is that it will, well, I technically showed it, but it will deepen the bed, the floor quite a lot. All right. Okay, so getting on with plucking. Plucking occurs on back walls of glaciers when the glacier is receiving precipitation from wherever, from a cloud here, it's receiving precipitation, right? It's building up here, and it's beginning to move faster as it moves downhill because of gravity. And what happens here is that as the glacier sort of moves out of its position, um, bits of rock are kind of plucked off. They're ripped off of the side of the glacier because the ice is actually attached to the rock, to the back wall. And what this does over time is, as well as creating sort of gaps in the wall, it makes the wall really steep in comparison to how it was before the glacier. Before the glacier was here, okay, and that's basically plucking. Okay, and and plucking, as I've already said, the thing that you have to mention if you're writing about it in a paragraph in an exam or something is that it steepens the back wall. Okay, so if you're talking about, for example, the formation of a quarry, you have to mention that plucking steepens the back wall and abrasion deepens the hollow, deepens the depression in the ground. Okay. Next, we have fracture and traction. So this one's super simple as well. You just have your landscape and you have your glacier. So in this one, we're going to draw a particularly thick glacier, okay? And what happens with this glacier is you get, not only do you get, because of the sheer weight of the glacier, not only do you get cracking just generally like all along the floor, right? Because of the sheer weight, it just puts so much pressure on there, and the ground starts to crack. Allowing rocks to sort of leave the ground and enter the glacier. Not only do you get that, but sort of a bonus point to add to this is that when you have different sort of rock types, so here you have soft rock, here you have hard rock, here you have soft rock again and hard rock. these areas of soft rock are likely to erode a lot faster, right? Because they can withhold less pressure, so they're likely to erode a lot faster than the hard rock. Okay, so you get a lot more erosion on the soft rock than you do on the hard rock, and what you're left with when the glacier melts is you're left with a landscape that sort of has varying levels of erosion, right? So here you have a little bit of erosion, and here in the soft rocks you have massive depressions, massive bits of erosion. You might be left with a bunch of debris from the glacier as well, if you want to sort of say that, and you're going to be left with a really uneven ground. Okay, and that is what fracture and traction does to the landscape. Okay, so there we are. Next one is meltwater erosion, and this is the final one. Okay, and so this one I would say is quite simple. You basically just have your glacier again, and you have your glacier here, and basically let's make it a little bit more complicated or a little bit more technical. Here is your line of equilibrium, so your precipitation occurs here, precipitation, and your ablation occurs here. So ablation is just the loss of mass from a glacier, right? Okay, and this is your ablation, that's your precipitation. What happens in the ablation zone is a bunch of water is melting because the temperature is quite high in this area or lower altitudes, right? So there's a lot more meltwater, and the meltwater forms here, and all the meltwater does is, well, I suppose it erodes. It can erode not only the ice but the rock as well. Okay, so the ice it sort of erodes because as the meltwater's, in fact, as the meltwater's traveling downhill. So let's get a little bit of a steeper gradient here. As the meltwater's traveling downhill, and you have your glacier, right? The meltwater is just going to absolutely smash into that glacier, and it's gonna into like bits of ice, and it's just gonna kind of erode that really quickly. And it's gonna do the same with, for example, rocks. So if you have boulder right here, right, the milled water is gonna just absolutely sort of smash into that and erode it really quickly, isn't it? And those are your methods of erosion.